गुड इवनिंग टू ऑल ऑफ यू। वेलकम टू गेट वाला। आई होप सब लोग अच्छे होंगे, मस्त होंगे। अभी तक हम लोगों ने इस सीरीज में बहुत सारे टॉपिक्स देखे, बट अगर मैं लास्ट जो हमने कल डिस्कशन किया था उसकी बात करूं तो कल हम लोगों ने बीओडी, बायोकेमिकल ऑक्सीजन डिमांड के बारे में पढ़ा था। उसकी बेसिक इंफॉर्मेशन ली थी हमने। बिफोर स्टार्टिंग बीओडी फिजिकल कैरेक्टरिस्टिक्स जो है उसके बारे में भी पढ़ा था। So today, now in this session, we actually going to study about the analytical method. Now, but before I will start the discussion, I just want to all of you guys to comment. Voice is clear to all of you now because today I'm using a new mic because from last few days you guys are complaining it about the old mic. Is it okay? Is it my voice is okay to all of you? Okay. Just confirm it in the chat section. Audible na? Okay. So what I was discussing, last class we have discussed about BOD, but we have only discussed the experimental method to find out the BOD value. Now in today's class, we actually gonna discuss about the analytical method to find out BOD. We'll solve some problems and then we'll also see COD, chemical oxygen demand, which is the topic of the day. And after COD, we'll also discuss total oxygen demand and the theoretical oxygen demand. So that will be the discussion for today. So first, let's start with the analytical method to estimate BOD. See, one method which we have seen in the last class, that was the experimental method. Now in analytical method, what we are doing it? First, we are making these two curves. So let me make that diagram first. These diagrams are very important for the analytical method estimation. In this diagram, in the y-axis you have time. In the y-axis you have time. Okay. Here you have organic matter. And here you have BOD, oxygen demand. Now you know that with the time, the organic matter concentration will decrease and it will decrease exponentially. It will decrease exponentially. Simultaneously, you will find as the organic matter is degrading, it is degrading by the bacteria, so they need some oxygen for that. So your oxygen demand will also keep on rising it. Your oxygen demand will also keep on rising it. Yes or no? So if you are considering for the maximum oxygen demand, that is what you are calling it as, L0. L0. So if you are focusing about the maximum organic matter, which will be definitely at time 0, because after time 0 or after starting time, the degradation will start and the organic matter concentration will go down. So at the beginning itself, at the time 0 itself, whatever the organic matter concentration will you have, accordingly you will have some maximum amount of oxygen. So that is what something which I have given as L0, ultimate BOD. We call this L0 as ultimate BOD. Now, at any particular time, if you talk about, let's say if you are talking about time t, after time t. So after time t, you will find this is the LT which is remaining for you. This is the organic matter which is remaining for you. And for that, if you check in the same time t, this much will be the BOD which is removed. This much will be the BOD removed. So The thing is that you will notice initially you have L0, that is something what we are writing it as organic matter concentration at the time 0. Now after time t, if you see, after time t, if you see, my dear, LT is the organic matter which is remain in the system. So how much it is removed? It is removed L0 minus LT. This much L0 minus NT. This much organic matter is removed after time t, or after degradation for t time. Now this L0, to remove L0 minus LT organic matter, we have used this much BOD. Can I say like this? So if you superimpose this curve and this curve on each other, you will find that this L0 minus LT, this is something giving you an idea about BOD removed, or I can say directly this L0 minus LT is related to the BOD removed. If L0 minus LT is more, definitely the BOD removal will be also more. To remove this much amount of organic matter, this much amount of oxygen is utilized. That's why in this particular time, same time t, you are getting this much BOD which is removed from the system. Am I clear? Now, this is the maximum oxygen content that we are considering it. Now, for the remaining organic matter, you will also have BOD remaining here. BOD remaining here. I don't think so anybody will have any issue here. I don't think so anybody will have any issue here. So first of all, I want to know in the chat section whether you have understood these two curves or not. Let me clear you first. See, what I am saying is this organic matter concentration is giving you idea about the BOD removal. See, I don't have any direct relation. I'm not saying that the organic matter will be same as the BOD removal. But to find out BOD removed, or you can write this as exerted. Sometimes they use the word exerted. Sometimes they use the word consumed. So this BOD is something which is indicating you this part or not, or this remaining organic matter is something which is indicating you the BOD remaining or not. That is what I want to know. That is what I wanted to know. Is that clear to all of you or not? Tell me quickly. Is that clear to all of you or not? Now, if this is clear to all of you, and you only look at this curve, organic matter curve, as I said to you that this organic matter degradation or organic matter will go with a decreasing exponential growth. So if you want to write an equation for this, what you will write? If L represents organic matter, if L represents organic matter, I can see many of you are not continuously active in the chat section. Until unless I'm not knowing what you are thinking in your mind, it is very difficult to teach in that case. So whatever your doubts are there, whether it's clear or not, you should definitely comment. Okay, so if L represents organic matter, for the exponential growth, I can write dl upon dt will be, or dl upon dt is directly proportional to LT. So dl upon dt, I can write this as K into LT. I'm using a constant K, which actually tells you the decay constant basically. It is a decreasing rate, so I'm using minus. If you put dt in that side, so it will be K into LT into dt. So K into dt, I'm writing it, divided by LT. If you integrate both the side, you will get ln LT equal to minus K into T plus some constant C. Now I have to find out this constant value. So I have to use some boundary condition. So what boundary condition you can suggest? We know that is already given in the diagram also, in the discussion also. When your time is 0, your LT will be equal to L0. LT is the remaining organic matter. L0 minus LT is the organic matter removed. So remaining organic matter at time 0, when the degradation is not started yet, that means what? At T equal to 0, your LT will be L0. So in that case, by that logic, by using this boundary condition, I got C equal to ln L0. Let us put this equation. So in that case, this equation will become putting C value in the equation, taking this as equation 1. So equation 1. So equation will become ln LT is equal to minus K into T plus ln L0. Okay. If you keep it in this side, so it will become ln LT upon L0 to the power minus KT. So I can write with this LT is equal to L0 e to the power minus KT. See, I can directly give you this equation also, because you know that in exponential growth, this equation is something which we are using it many times. So LT equal to L0 e to the power minus KT. This equation is important for us because this equation gives you a relation between the organic matter remaining after time t, the organic matter at time 0, K is the rate of reaction and T is the time. Here, if you want, I can write this. L0 is the organic matter concentration after time t. Sorry, organic matter concentration at T equal to 0. LT is the remaining organic matter concentration after time t. K is the rate of reaction, and the unit for the rate of reaction I am taking as D inverse. That means it is a first order reaction. That means the unit itself will tell you it is nothing but the first order reaction. Now once you got this LT, now it's very easy for us to find out two things. First one will be the BOD remaining, which is something I am saying it is nothing but equivalent to what? Organic matter remaining after time t, and that is equal to something what we write this as LT, and that is equal to L0 e to the power minus K into T. This became a formula for you. This became a formula for you. Second thing what they will ask you to find out BOD. Sometime we also call this as BOD removed, or sometime they will simply say BOD. BOD means BOD removed they are talking about. If they want you to find out BOD remaining, they will mention in that question exerted or consumed. So this is something which is equal to organic matter removed after time So it is equal to L0 minus LT. If you take L0 common, so it will become e to the power minus k into t. Again, this formula is very, very important for all of you to remember. So you got the formula for BOD remaining also, you got the formula for BOD removed also. As I said, BOD removed means BOD consumed, BOD exerted, or simply you can say BOD. Clear? Clear? Let us say if you wanted to find out BOD pipe at 20 degrees Celsius. So how you will write the formula for that? See, L0 is not something which is dependent on temperature. It is the initial organic matter concentration. So that is not dependent at what temperature you are doing the degradation. But BOD is something which is dependent on temperature. How? Because in that equation you have 1 minus e to the power k is the rate of reaction, and rate of reaction always depends on temperature. So e to the power minus K20 into 5. This will be the formula. This will be the formula. Now definitely then you guys will ask me, sir, what happens if I have to find out for different temperature? So for that we have a simple relation, KT equal to K20 1.047 T minus 20, where T is in T you have to put in degree Celsius, and or you can say T is in temperature. This 1.047 is something what we are calling it as temperature coefficient. Always remember, if in the question they have mentioned something different, then you should take that only as a temperature coefficient. In general, you can use this one, 1.047 to the power T minus 20. 1.047 to the power T minus 20. KT is equal to K20 1.047 to the power T minus 20. So this is what the formula is. This is what the formula is. Clear to all of you? I don't think so anybody will have any doubt in this. Now just to let you know whether you have understood this formula or not, I'm giving a small example to all of you. Before going to that, see, this is a curve, the BOD curve which we have discussed yesterday. Now you can see this BOD value, how this curve is responding to it for the different rate of reaction at different temperature. For example, you have 3 rate of reaction which is mentioned here. One is K1, another is K2, another is K3. And in this sequence, your temperature is also rising it. So obvious thing is that your K1 will be the smaller one, then K2, then the K3. So your rate of reaction K3 is greater than K2, K2 is greater than K1. Because your temperature is increasing as you are going from 1 to 3. So rate of reaction will also increase. Now if rate of reaction will increase, because of that, what happens with the BOD curve? Right now the curve which I am showing it to you, it is the first stage BOD. As I said, we are focusing more on first stage BOD because generally 5 to 8 days which we are taking it. So in that case, the first stage BOD will be important for us. Now if you see here, as the rate of reaction is increasing it, this curve is shifting to the left. Why it is doing so? Because what happens if you increase the rate of reaction, the higher BOD you will get it at, like for example here the maximum BOD you are getting as here 5-day. Now the same BOD you are getting it at a lesser time. It is very simple, because if you increase the rate of reaction, the same BOD amount you will get in a lesser number of days. Again, the maximum BOD you are getting it as, so this one is T1, this one is T2, and this one is T3. So it's quite obvious that if rate of reaction is higher, in that case you will notice the T3 will be the minimum, then the T2, and then the T1. So if your rate of reaction is increasing, your time will go down for the same constant BOD if you are talking it. For that reason, what happens? This curve is shifting to the left. Why? Because you are getting maximum value at lesser time itself. In the less time itself, you are getting the maximum value. So you will get a peak here, and after that it will become flatter. So that is something which you can say that this curve is slightly going towards the left. Is that clear? So this is the basic reaction kinetics that you can understand here with this diagram. Okay. Now, as I said, I will give you a question and that you all have to try. See this question. Try this question. First read the question properly. All of you, first read the question properly. That is the first thing which you require. First read the question properly. Question is saying it, two wastewater stream A and B. So I'm just showing you in the picture two wastewater stream, which is A and B. These two gets mixed up, and these two are having identical ultimate BOD. So they have the same ultimate BOD, L0, L0. Are getting mixed to form stream C. The temperature of the stream A is 20 degrees Celsius. So here the temperature is, as they are saying it, it is 20 degrees Celsius. The temperature of stream A is 20 degrees Celsius and the temperature of stream C is 10 degrees Celsius. So that is change in the temperature. So but basically what they are discussing it in the chat section. Okay. So basically, when you change the temperature, the rate of reaction will also change. Am I right? It is given that 5-day BOD of the stream A measured at 20 degrees Celsius, that is 50 milligram per liter BOD. So they have given you 5-day BOD for stream A. So the data which they have mentioned, it is 5-day BOD for stream A at a 20 degrees Celsius. So that is 20 degrees Celsius and that is 50 milligram per liter. Now they have given you the BOD rate constant also, that is K, and that is something they have given it as base 10, which is 0.115 day inverse. Temperature coefficient also they have given it to you. So that is 1.135. That is a temperature coefficient. Now what they want from you is the 5-day BOD of the stream C calculated at 10 degrees Celsius. Now see the solution first. What they want from you, let me write that first. It is BOD at 5 day at 10 degrees Celsius for stream C. As you know, both A and B are having the same ultimate BOD, So the mixture will also have the same BOD. Am I right or wrong? If you mix A and B and both are having the same ultimate BOD, so in that case, even the C will also have the same BOD. Am I right or wrong? So for C, I'm using the same ultimate BOD, which is L0, 1 minus e to the power right now, K is for 10 degrees Celsius and the time it is given 5. So I will write 5. Now, if you see in this question, two things it is not mentioned that you need actually. One is the ultimate BOD, another is the K10. These two values are not given to you. So you have to calculate it first. So one by one. First, if I write K10, as we know, K10 will become equal to K20 into temperature coefficient. They have mentioned it as 1.135 T minus 20. So T is 10 minus 20. T is the temperature, 10 degrees Celsius, and minus 20. Now K20. K20 is already given to you 0.115. But the issue is what? Issue is that they have given as a base 10. And the formula which we are using it is e to the power something. That means I'm using as a base e. So I have to multiply this value 0.115 with 2.303 to convert this value into base e. Okay, now if you have converted this value, then multiply with 1.135 to the power 10 minus 20. Can you guys give me the value of K10? Those who are solving it, give me the value quickly. Let's see whether your answer and my answers are matching or not. So it is 0.046. 0.0746 day inverse. So K10 is 0.0746. Basically, you decreases the temperature, so obvious thing is that your rate of reaction will go down. It's quite logical. Now the second thing comes, that is the ultimate BOD. They have given you a data that BOD for 5 day at 20 degrees Celsius for A stream, it is given as 50 milligram per liter as per the data. I know this is nothing but equal to L0, 1 minus K to the power 20 into 5 equal to 50. So if I wanted to calculate L0, see this L0 which I am getting it for the stream A will be used for stream B also and will be used for stream C also. The same ultimate BOD will be used here. So that's why I'm finding this value L0. So it will be 50 divided by 1 minus e to the power K20 is 0.115 into 2.303 and the number of days we have 5. So can you give me the value of L0 in milligram per liter? Can you give me the value of L0? So it is 68.1207. It is 68.1207. 68.1207. This is the L0 value which I got. All of you should also do the calculation so that you can check if any numerical mistake is done by me. You guys can cross check that part. Simply copying pasting will not help you. So you wanted to find out this. L0 is 68.121207, I think. Okay. 1 minus e to the power k value is 0.0 into 5, bracket closed. $21.208. $21.208. $21.208. This is what the answer which I am getting. Anyone having any doubt in this question, please let me know. If anyone having even a small doubt in this question, please let me know, my dear. Clear to all of you? Clear to all of you? Okay. Now we'll go for the next part, which is the COD. That is the topic of discussion for today. Chemical oxygen demand. First, see the definition itself. When we say COD, the full form is chemical oxygen demand. It is something which is defined as amount of oxygen required or demanded to oxidize both biodegradable and non-biodegradable. In the BOD, we have only taken the biodegradable organic matter, but now here we are taking the biodegradable also and the non-biodegradable organic matter also present in the wastewater. Now it's very simple to understand that, see, biodegradable organic matter that will oxidize, they need some oxygen. That is what you have given as BOD, biochemical oxygen demand. But for non-biodegradable organic matter to oxidize them, to degrade them, you need a strong chemical oxidant. Here also we are doing the same. We are using a strong chemical oxidant such as potassium dichromate K2Cr2O7. Potassium dichromate. Is it working? It's working. Potassium dichromate K2Cr2O7. Is that clear? K2Cr2O7. Now see, in the COD test, what we are doing it. First of all, in the COD test, one doubt came in the chat section from Priyanka. Sir, 2.303 you have taken. Yes, I have taken 2.303 in the previous question because the value of K was given in base 10. And the formula which I am using it, that was L0 bracket e to the power 1 minus e to the power K into T, where the K value which I am using it will be in a base E. So I have to convert that value into base E. For that reason, I have multiplied 2.303. Is that clear? Go back to the calculation. That's why I have taken this. Clear? Doubt clear, Priyanka? Okay. Now in the COD test, first of all, COD is estimated by a reflex apparatus, that is COD digester that we are calling it. But in the COD test, some reagents we are using it. First of all, you remember all the reagent first. Potassium dichromate, which is basically you are using it as an oxidant, because here you are dealing with the non-biodegradable organic matter also. To degrade them, you need some strong oxidant. Then you need mercuric sulfate. Why? Because in this sample, in this wastewater sample, maybe there will be some amount of chlorine. So chlorine is also an oxidizing agent, as you already know. Chlorine is also a oxidizing agent. So if this oxidizing agent will be there, then how much amount you are adding for the potassium dichromate, it will be not in a perfect way, na? It will actually interference, it will create some interference in the oxidizing nature, because some amount of chlorine is already there. So if you want to inhibit the interference of chlorine, you are adding a inhibitor which is called as mercuric sulfate, which will actually inhibit the interference of chlorine, so that this potassium dichromate can freely work, and we can also calculate the amount, how much it is required. Silver sulfate for the as a catalyst, it will be giving. Concentrated H2SO4 is required because the complete process will be in acidic medium. So you need to give concentrated H2SO4 for that. Now, once the sample is ready, then you have to go for titration process. In a titration process, you already know two things are important in the titration process. One is the titrant, which is here ferrous ammonium sulfate, NH4 twice, FeSO4 twice, .6H2O, FAS. In short, we write it FAS. So that will be the titrant which we are using it, and the indicator will be ferroin. The ferroin indicator which we are using it for the titration process. Now see the complete method in a single chart. I am showing it to you. Please let me know quickly whether this chart is visible to all of you or not, because this is in white slide. So is it visible to all of you? Okay. So what we are doing it, we have a water sample container, and then we have a distilled water in the container, in a small container. So from both, two tube we are taking it. One tube we are filling the water sample, in another tube we are filling the distilled water. Sir, why you are doing test for distilled water? Because I wanted to find out how much basic, I wanted to find out how much COD is present in the distilled water itself, so that much part I have to remove it from the main data. So for that reason I am finding that even for a blank solution, how much COD value you are getting it, that I wanted to find it out, so that part I will subtract from the water sample data. So in both the tube, in the first tube I have taken 2.5 ml of wastewater sample. In the second tube I have taken 2.5 ml of distilled water sample. Now you add 1.5 ml of potassium dichromate. It is nothing but an oxidant. So once you add this 1.5 ml of potassium dichromate, then you will add H2SO4 for the acidic medium condition. So carefully add 3.5 ml of sulfuric acid reagent to both the tubes. See, whatever step you are doing it, we are doing it for both the vials, both the tubes. Then you put that tube into the COD digester for a digestion period of 2 hours at a 150 degrees Celsius. So 150 degrees Celsius, and the time is 2 hours. Once it is digested for the next 2 hours, then you take it out, cool it down, and then separately you put this into this type of conical flask. So after cooling to room temperature, transfer this vial or transfer this tube into a conical flask, not in a mixed format. That means if two vials are there, so you will have two conical flasks also. One is for the distilled water, another is for the wastewater sample. Now this conical flask, which is now completely cooled down sample, in this cooled down sample, completely cooled sample, now we are doing the titration process. Now for titration process, you need ferrous ammonium sulfate, which is FAS. It will be put into the beaker, burette, and then slowly you will start, you will add some amount of FAS. At certain point you will get the data. But to know when is the starting point, when is the ending point, to know that, we are adding a indicator also. Here we are adding indicator as ferroin. So we are adding 2 drops of ferroin indicator before doing the titration process, before adding the titrant into the sample, and then titrate the content against ferrous ammonium sulfate Continue the titration till the color changes to reddish brown. So once you add this ferroin indicator, from that you have to do the titration process till the color changes to reddish brown like this. At that point you have to stop, find out the volume, and then you can find out the COD concentration, just same as what you do in the normality test. N1 V1 equal to N2 V2, that condition you have to use it, and in that way you can find it out. So all the steps for the COD test, have you all understood? Any steps which you are not clear? If any steps you are having a doubt, you can simply ask. Okay. Now the next demand is total oxygen demand. Now the total oxygen demand, it is actually the amount of oxygen required to oxidize biodegradable and non-biodegradable organic matter along with few inorganic chemical substances which are oxidizable. So in the total oxygen demand, you are targeting not only the organic matter, you are targeting inorganic matter also, but in inorganic matter, not all inorganic matter, only those which are oxidizable. So if you try to make a relation between these, you can simply write like this: your BOD5 is definitely lesser than BOD, ultimate BOD. Your ultimate BOD is lesser than COD. Your COD is lesser than TOD. This can be the relation. This can be the relation between these. Sometimes they can ask you this relation also. Sometime they can ask you about this relation also. Clear to all of you, my dear? Is that clear to all of you, my dear? So up to this, if it is clear, please let me know. Clear to all of you? Okay. Now we are going for the next one, which is theoretical oxygen demand. Theoretical oxygen demand. By definition, it looks very easy. What it is actually telling it to you? It is the oxygen demand estimated by the relation between oxygen and substance in a chemical reaction which are oxidizable. It is very simple for you to understand. For example, C plus O2, it gives you CO2. So you know that the 12 gram of carbon need 16 into 2, 32 gram of oxygen, and that will produce 44 gram of carbon dioxide. So per gram of 1 gram of carbon required 32 divided by 12 gram of oxygen. Am I right or wrong? So like that, if you are calculating the oxygen demand, that is what we are calling it as theoretical oxygen demand. Theoretical oxygen demand. Now to understand this in a much better way, and even one more point I want you guys to learn, which is the total organic carbon. And for that, let me take a question for all of you. Read this question first. Just read this question once. So question is telling you, calculate the theoretical oxygen demand and organic carbon concentration of water that contained 200 milligram per liter of glucose, which is C6H12O6, and 25 milligram per liter of benzene, which is C6H6. Rishi Verma is asking, sir, if I have covered mostly syllabus leaving 3-4 subjects like mechanics, CPM, irrigation, environment, would it be recommended to purchase Vijay batch? See, if you have not covered the entire syllabus, in that case, Vijay batch will not be good for you, Rishi. Vijay batch is for dropper who have already covered the whole syllabus, and they are only taking the batches for revision, doubt discussion, and the practice part. Some good questions if you want to practice. So that is the only purpose of Vijay batch, and that's how you can improve your rank. If you are taking Vijay batch by thinking that, or in your mind if you are thinking like that, I will cover environment with the Vijay batch, or I will cover CPM irrigation with the Vijay batch, in that case you will be in trouble. So Vijay batch is for repeaters or droppers who have already covered the whole syllabus with the comprehensive batch or by their own, and then they are coming for doubt discussions, practice, because you definitely gonna get very good question for practice in the Vijay batch, and the revision part. Three things, three important pillars: revision, practice good questions, and doubt discussions. That will be the whole, in a simple word, if I will tell you, that is the whole discussion for the Vijay batch, and that's how you can improve your rank. But don't expect in a Vijay batch you will be getting everything what you are getting in the comprehensive batch. So subject preparation is something which is started with first the comprehensive batch, then only you can join the Vijay batch. Clear? Okay. Now here they are asking two things. One is the theoretical oxygen demand, that is just now we have seen. Another is the organic carbon concentration. Organic carbon concentration. Okay. Now the next question, this is asking, so sir, can I cover the leftover subject from 𝐂𝐤𝐬𝐿 and rest from Vijay? You can do that. Taking Vijay batch and with 𝐂𝐤𝐬𝐿, you can manage. 𝐂𝐤𝐬𝐿 is the only thing is that you are going to get the classes in recorded format, and it will be a generally 1 year back. Especially for this year, I will not suggest you to go with 𝐂𝐤𝐬𝐿. The issue is the same. In the 𝐂𝐤𝐬𝐿, the previous year lectures will be recorded, and this year there is slight change in the syllabus. So I will actually request you to take the new batches, so that all the new content will be also new syllabus change content will be given to you. So now 𝐂𝐤𝐬𝐿, if you are watching it, maybe some part you will miss it, especially those part which are included in the new syllabus. That's something you will miss it. Like for example, in environment, the tertiary treatment is newly added, so that part you will miss it. Okay. Now let's come to the discussion, Rishi. Later on we can discuss about that your doubt also, if it is not clear. So we are talking about theoretical oxygen demand and the organic carbon concentration, and you have 200 milligram of glucose and 25 milligram per liter of benzene. So you need to know both the, like for glucose, if it is the formula is C6H12O6, it needs some amount of oxygen and it will be converted into 6CO2, am I right? Plus H2O, then it will be 6H2O. Now you have to balance the oxygen part. This side you have 6 into 2, 12 plus 6, 18 oxygen, and this side already 6 you have, so 18 minus 6, it will be 12. Then this 6O2 will be the perfect balance. Similarly, for C6H6, if you want to calculate C6H6, it will also react with oxygen to form 6CO2, because you have C6 now, so 6CO2 will definitely form, plus some amount of oxygen, some amount of water, not oxygen. H6 is there, so this will be 3H2O. So 3O plus 12. So total it will be 15 oxygen. So in that case, here you have to write 7.5. Am I clear? Now see here, the molecular mass of it is 180. The molecular mass of this is 12 into 6, 72 plus 6, 78. The amount of oxygen you are needing is 6 into 32. Am I right? And this side it is 7.5 into 32. It's clear? Now first thing, if you want to find out theoretical oxygen demand demanded by the glucose, how you will calculate it? 180 gram of glucose required 6 into 32 gram of oxygen. So for 1 unit of glucose, how much oxygen is required? 6 into 32 divided by 180. Right now, what is the concentration of glucose we have in the sample? It is 200 milligram per liter. So if you want it for 200 milligram per liter, simply multiply and you will get the oxygen content or oxygen demand required by the glucose. Similarly, if you do it, if you will do it for the benzene part, it will be 7.5 into 32 divided by 78 into right now the benzene is 25 milligram per liter. So the total theoretical oxygen demand you can find out, and according to Himanshu it is 290.25. Is it? Let me calculate and check whether you guys are right or wrong. Yes, so Himanshu, I think he has given completely right answer. 290.2564. This is the theoretical oxygen demand. Now, similarly, if I will write for next thing, what they want you to find out is the organic carbon concentration. So TOC, total organic carbon concentration, if you want to find out, you know, in glucose, out of 180 gram, for 1 mole I am talking about, out of 180 gram, you have 6 into 12, which is 72 gram of carbon. So 72 gram divided by 180, that means for 1 unit, you have 72 divided by 180. Right now, what's the concentration they have given you? 200 milligram per liter. So you will get for a 200 milligram per liter of glucose, how much amount of organic carbon will be there. Now, in the benzene part, total molecular mass is 78, but out of 78, 72, 6 into 12, 72 gram is the carbon. So per unit, it will be 72 divided by 78. Right now, the concentration which they have given you, it is 25. So if you calculate it again, so Himanshu has given both the answer correctly. Very good, bacha. 103.076 milligram per liter. That is the total organic carbon. That is the total organic carbon. Okay. Now tell me whether all of you have understood what is theoretical oxygen demand and what is total organic carbon. Is that part is clear to all of you or not? Tell me quickly. This both part you guys have understood or not? Now Himanshu is telling, sir, I have studied environment last year from you and currently revising from Vijay batch. Will tertiary treatment and new topics discussed as in the last year batch it was not discussed? See, if it is a last year batch, definitely what you can, I will give you two, I will say suggestion. First of all, if you're in your Vijay batch, if environment is not covered, so definitely some part from the new topic which is added, tertiary treatment, so that will be discussed in the Vijay batch. Because if in Vijay batch environment is not covered, if it is covered, then we have to put it as a recorded for you. And regarding general student, will come up with some YouTube session also for you in future for the new part which is added. So no need to worry about right now. Whatever which you have already studied, try to revise in best possible way. Regarding the new part which is added, those who are already in the batches will definitely help you with either live classes or the recorded content. It will be provided to you. Those who are in a current year batch, those who have completed environment like last year or maybe 1 or 2 years back, for them also I am telling you, no need to worry about, will help you in a best possible way. Even if you have to come with on YouTube for that new part will come up. So no need to worry about that. Especially in new things we have to study in environment. Already it is there is a separate video which we have recorded in the channel. I think you can check that in the video recorded section. So already it is given. If you want me to answer this, especially tertiary treatment is something which is newly added. Tertiary treatment, not much. Only some part of tertiary treatment will be discussed and no need to worry about that. Next, Priyanka is asking, sir, mission AIR less than 100 is beneficial or not for GATE 27? It is beneficial. That's why we are teaching it now. But don't think that some of you guys will think, sir, oh, this is the whole environment. No, I'm taking how many classes? 7 to 8 classes for environment. Like after today's class, we have now 2 more classes for environment. One will be plume behavior discussion, another will be oxygen sac curve discussion. But this is not the whole environment. But definitely with this classes, you are getting the benefit of learning the subject on YouTube and asking your doubt, making sure that this topic is now completely clear for all of you. So it is definitely a beneficial for whether you want to achieve your best rank, it is definitely beneficial for GATE 2027. Okay. So that is the 2 doubt which you guys have asked. I think now that doubt is clear. So as I said already, these are the topics I want to discuss, but at the last with one problem, we'll close this class. So in this session from the yesterday class to today's class, we have covered the characteristics of wastewater. In that mainly we have discussed BOD, COD, TOD, THOD and the organic carbon concentration. All these topics we have discussed. Let us solve this question quickly. Yes, sir, environment not covered in Vijay batch. If it is not covered, then definitely some part of the new syllabus, which is important for the GATE 2027, will be discussed in Vijay batch in a form of question, in a form of revision. So no need to worry about that. You have to understand this. This is actually our responsibility as a teacher to provide you the content which is required for the exam. So no need to worry about anything. Even something, if it is added or removed, each and everything will be informed to you. For that, what you have to do, you have to simply stay connected and be active in the session whenever you are attending any session. That's the only thing it is needed. It is our responsibility, and we are actually very good in civil engineering discussion part, that whichever which is required for the exam will definitely help you. Two things they are asking you here. Here in this question, they are asking you first 5-day BOD and the ultimate BOD. So basically this question is a combination of the experimental method which I told you yesterday for the BOD measurement and the analytical method which I told you today. So both the method will be used in this question. Both the methods will be used in this question. First of all, DO of aerated water used for dilution. So that means they have given you the DOD part. DO of diluted sample after 5 days of incubation. That means they have given you DO final part. DO of original sample. That means they have given you the DO of sewage. Either you can write DOS or DOW. The first thing I have to find out will be the DO initial, which is nothing but equal to the DO mix, and that will be equal to DOD into VD plus DOS into VS divided by VD plus VS. So DO in, how much you guys are getting it? DOD, it is 3% dilution. That means 97% will be the diluted water or diluted water which you have used for the dilution purpose, and DOS is 0.6 into 3 divided by 100. So anybody who have done the calculation, you guys can give me the value of DO initial. All of you give me the value of DO initial. So now when you have the DO initial value, you have the DO final value which is already given to you. I think you guys can simply calculate the BOD for 5 days. It will be DO initial minus DO final into dilution factor. So DO initial, I am waiting for you guys to respond quickly. What will be the DO initial value? DO final is already given to you, which is 0.6, and the dilution factor, 3% dilution, that means dilution factor will be 100 divided by 3. So how much initial DO you guys are getting it? Only Himanshu has answered. Waiting for other guys to answer so that I can match the answer. I'm getting around 2.928. 2.928. So 2.928. What will be the BOD 5 value? (2.928) minus 0.6. It is 2.328 into 100 divided by 3. So I'm getting around 77.6 milligram per liter. My answer and Himanshu's values are not matching. Okay, so I'm getting this only BOD 5, 77.6. Now they want ultimate BOD also. So we know ultimate BOD is equal to, if you have the BOD 5 value given, so it will be 1 minus e to the power k into 5. BOD 5 we have calculated 77.6, 1 minus k. The value of k they have given 0.1 day inverse. That means actually they have given this value in base 10. This value 0.1 is something which is in base 10. So I have to multiply this value 0.1 into 2.303 to convert this value into base e and then multiply by 5. According to the calculation, I am getting around 113.477 milligram per liter. Sir, 0.8 होगा ना? Which one? Oh, sorry. DO final is given 0.8. That is my mistake, bacha. I picked this value. DO final is 0.8 now, which is given to you. In that case, answer will have some changes. So I'm getting 70.9334. 70.9334. One zero three point seven two eight. 103.728. 103.728 milligram per liter. Clear? Clear to all of you? Okay. Now with this, we have completed the today's discussion. I think tomorrow's topic will be plume behavior. If I'm not wrong, tomorrow's topic of discussion will be plume behavior. So we'll again meet tomorrow at same timing, 6 p.m. Till then, take care. Bye-bye. Good night. Sabah khair. Bye-bye. Jai Hind. Still, if you are having any doubt, you can always discuss with me here. Okay.